Today we're talking about rational exponents. Exponents. So exponents and radicals are kind of like brother and sister, or like the opposite. They go as a pair. Just like adding, subtracting, multiplying, dividing. The opposite of a radical is like an exponent, and you can always write every radical or root as an exponent. These are all the properties of exponents, so I'm going to go through them one by one. And I wouldn't write out this whole chart. I would just write out what makes sense to you. So first, you always have to have the same base when doing any of these properties. And what does base mean? It has to be the same number here. I couldn't have 3 squared times 2 to the third. These two do not have the same base because the base is the large number. So first, they have to have the same base. If I have the same base, 3 squared plus 3 to the third, then I can add the two exponents together and I would get 3 to the fifth. So if they have the same base and they're being multiplied, you add the exponents. If there's a base, like 3 to the third, and it's raised to the fifth power, that's when you would multiply a power to a power you multiply. So this would be 3 to the 15th. And let's say if I have 3x, and this is raised to the third, you have to distribute to everyone on the inside. So it goes to 3 and goes to x. So this would be 3 to the third, x to the third, and you should always simplify your answer. So in this case, this would be 27x to the third, because 3 cubed is 27. And then the next property, we never want any negative exponents. Negative exponents are no good. So if I have a negative exponent, if I had, let's just keep on working with 3 to the negative 2, I can rewrite that as 1 over 3 squared. Because negative exponents would just bring it to the bottom of the fraction, or if it was negative on bottom, it brings it to the top. And just like when we have multiplying with the same base, if we're dividing with the same base, let's say 3 to the second over 3 to the fifth, I would subtract those exponents. So in this case, it would be 2 minus 5, 3 to the negative 3, except again, I don't want to leave it as a negative exponent. I would change that to 1 over 3 to the third. And just like when I talked about multiplying with the same base, or with different bases, if I had 2 over x, and this was being cubed, you still have to give it to everyone on the inside. So I have to bring the 2 into the, or the 3 into the 2 and to the x. So this would be 2 cubed over x cubed, and again, you have to simplify your numbers. So if you haven't caught on yet, we're going to be bringing some variables into our problems. And the last property is actually, how do I get a radical to an exponent? So if you have a radical, this index here is part of your exponent. The index is like an exponent except it's written as a fraction. So I could rewrite this problem as 27x to the sixth to the 1/3 power. So any radical, the index will indicate what should the fraction exponent look like. When we're dealing with these problems and we have numbers like 27, you should always write out your number in prime factorization. So if you want to, you could do your factor tree, get 3 and 9, 3 and 3. So I'm going to rewrite this problem as 3 to the third, because there's 3 there's. And then I have x to the sixth, and I'm still to the 1/3 power. So now if I remember my property for exponents, now I can multiply the 1/3 inside my fraction. So this would become 3 to the 3 over 3, x to the 6 over 3, because I'm multiplying the 1/3 by each exponent. So my final answer here would really look like 3x squared. Or else you could have 3 to the first, because 3 over 3 reduces to 1. And 6 over 3 reduces to 2. So that's how we rewrite any radical as an exponent. So here I want to simplify each expression, and I want you to be working with exponents now, not radicals. So for the first one, you should do your factor tree. So that's my factor tree, and now I'm going to rewrite this as my prime factorization. So in parentheses, I have 1, 2, 3 2s, so I'm going to have 2 cubed times, I have 1, 2, 3, 3, so it's going to be 3 cubed. And it's to the 1/3 power. So once I get my prime factorization, then I can multiply my exponent in. And remember, it has to be multiplied by everything on the inside. So this would become 2 to the 1st power, because 3 times 1/3 is 1, and 3 to the 1st power. So my final problem here would be 2 to the 6. So that would be my answer. 2/16 raised to the 1/3 power is 6. For B, since I have the same base here, they're both 7s, that means I add my exponents. So adding exponents would be 7 to the 1/2 plus 1/2. And if you remember adding with fractions, you have to have the same denominator. In this case, I do. So it's going to be 7 to the 2/2 power. So when you're adding fractions, it's going to be 1 plus 1, and that's where I get the 2. Denominator stays the same. So my final answer would just be 7, or 7 to the 1st power. So again, here I want to simplify. So the first thing I want to do is rewrite 125, so it's prime factorization. I know, so I'm going to rewrite 5 to the 1/4. 125 is the same thing as 5 to the 3rd power. Then I'm going to have 1/4. So I'm going to simplify this exponents right here. So this is 5 to the 1/4 times 5 to the 3/4, because power to a power you multiply. And now since I have the same base here, 5 and 5, now I can add these two exponents together. So I'd have 1/4 plus 3/4, which would be 4 to the 4th. It's going to be equal to 5. I know that all these problems are simplifying out to just be the number, but that is not always going to be the case. So here's just a little practice with roots. So there's actually 2 problems here. For each one of these, I want to write each problem so that it's an exponential form. So if in this first one, remember if there's no index, that's like a 2 there. So whatever the index is going to be like a fraction. So this would be a to the 5th, and then raised to the 1/2 power. You have to distribute this. If you are good at this, you could go straight to this step. So it would be a to the 5/2. Right now I want you to pause the video and see if you can write the second one correctly. You should have gotten b to the 3/5 power. So I want to write this radical fraction to simplest form. First, a few things. We never want any negative exponents, and if we have a variable, like in this case we have x, we only want one x in our answer. So first, change everything to exponents. So on top, this would be x to the 3/4, because again, this index would be on the bottom of the fraction, and on the bottom would be x to the 2/8. Now I can simplify the bottom of the fraction, because I know that 2/8 is the same thing as 1/4. So now since I'm dividing, I want to use my exponent properties. So I'm dividing with the same base, in this case it's x. I can subtract my exponents. So I would have x to the 3/4 minus 1/4, and that's going to be equal to x to the 2/4, which is the exact same thing as x to the 1/2. So it's just simplifying once you know your properties. Right now I want you to pause the video. Yes, pause the video and attempt both A and B by yourself. Again, your first step is always to change everything to an exponent. The first one, so you want to change it to the exponents, and you're going to have 1/2 and 1/4. And when you add those two exponents together, you can't add two fractions until they have common denominators. So I had to change 1/2 to 2/4, and so my final answer was 3 to the 3/4 power. Same thing for B. I can divide, so that's subtracting my exponents, but I had to first change them so they had common denominators. So I changed it so that I had 6 on the bottom. Once I subtract, it's just the top two numbers would be 5, 6. Make sure you wrote down all of your notes, and have a wonderful evening.